In this video, we will learn how to manage inventory using normal distribution theory. First of all, read the problem. For this problem, there is some construction company. Uh, Suppose you are this manager, and this manager knows daily demand. This daily demand follows normal distribution. And daily demand, actually this is not weekly demand, daily demand has mean of 50 and standard deviation is 5 tons. So then now think about this, and daily demand day one, so it follows normal distribution, and this case 50 mean 5 standard deviation. And for this case, we do not use one single day for delivery. For delivery, it takes 4 days. 4 days. That means what? We have to take into account this 4 days demand. Then you have to take D1, D2, D3, D4. This is actually our new D. This is demand during delivery time. And then now also we have to think about this stock out risk. This stock out risk should be 3%. So then now think about our general inventory profile timeline on x-axis, y. So we have inventory. We have a certain inventory, and every day we sell certain, you know, we have certain sales. The inventory will decrease, right? At certain point you have to reorder. So this is ROP. ROP stands for reorder point. At this point you have to reorder. Then from this day, it takes 4 days. During these 4 days, your demand can be enough to manage your inventory, or some case your demand can be very high. Then your inventory can go down or negative. If you have a negative inventory, then that case you have a back order. Back order. Back order means you have a negative inventory. Negative inventory means you receive order and you promise you deliver that order later when you have inventory. That's a back order. Otherwise, your customer cannot wait and you lose those opportunity. Then customer will leave, then you lost sales. Then your inventory will go down and will be zero all the time up to your receiving date. At the receiving date, you receive uh, your order quantity, right? And you receive this order quantity, and you can start the next cycle. And next cycle, you have some demand like this, and at certain point, again, if your inventory reached to this point, and you have to reorder, and right from here it takes another 4 days. This is the delivery date, and during this delivery date your inventory, your demands looks like this, and you receive another inventory here, and you get inventory. And this is inventory profile, means you have to manage your inventory. uh, every time you have to decide your reorder point to satisfy your customer service. For this case, your stock out risk should be less than 3%. So now think about stock out. When do you have a stock out? Stock out is if your demand is greater than your inventory, or your supply, right? So economics and the supply chain uh, deals with this matching demand with the supply. So demand is, if demand is greater than supply, then this case is what? Stock out. Then now we have to compute the probability of stock out. This stock out should be less than 3%. When do you have a stock out? So stock out is actually demand is greater than your demand during your delivery day for next 4 day is greater than your reorder point. This is actually 0.03. So actually, back to our this case, daily demand. This is not 4 days demand. Daily demands we have a 50. Every day you have a 50 and standard deviation 5, and our demand for delivery time is a sum of 4 days demand. Suppose these demands are independent and identical, that you have to add up. Then what is new demand distribution? Demand is follows 4 times 50, 4 times variance. Then again, you can rewrite this case. If you have every day 50 demand, then during 4 days your average demand will be 4 times 50, 200. And your variance is 25. I mean standard deviation 5, but your variance is 25. Then next 4 days demand variance will be sum of all these demand, but not sum of standard deviation. This is kind of statistical theory, but I don't explain those statistical theory. But I believe you learned that part. Then for this case, you have a 4 times 25 is 100. Then that means you have 10 square. Then this means your uh, mean is 200, and sigma for next 4 days is 10, not 5. So then with this, so now you can compute this one, right? So back to our problem. Then now P of stock out is equal to probable demand is greater than ROP, and this is actually 0.03. And draw graph again, draw graph. Your ROP is greater than certain number. Actually this is 0.3. Then what is this probability? Left side area 0.97. Then you can use 0.97 as our inverse probability number, right? Then for this case you can use lambda inverse, and probability is 0.97. Mean value, what is mean value? 200. What is standard deviation? 10. So then you have, if you have 219, your reorder point is 218.9, or almost 219, not 18.8. 18.8 is not integer number. So then if you have 219, then your stock out will be almost 3%. So we solved this problem. Second problem, what is stock out probability if your reorder points are 220? So then this is first question. First question is like this. What is second question? Second question is probability demand is greater than 220. What is this probability? Then how can you compute? This case 1 minus P of demand is 220. So we will use this probability function. So for this case, our second question is probability of demand is greater than 220. I mean stock out reorder point here, right? Reorder point is 220. Then we want to compute the stock out. Stock out probability is demand is greater than this reorder point. Then this is greater than. Then you can change this direction. And finally, this case 1 minus norm dot dist x is 220. What is mean? Mean is 200. What is standard deviation? Standard deviation is 10, and this is cumulative. So 2%. First question, 3% case, reorder point is 219. If you have 219, then it will cover 97% of your in stock, right? In stock probability. But if your reorder point is given 220, then that probability is only 2%. So please practice this problem, and this problem is we apply normal distribution probability theory to real supply chain example.